So last time we called it imaginary tuple variable, because you cannot see it. You can only imagine, So when you understand the query statement, so many times you need to really spend a lot of time understand the structure of the query statement. So this concept is useful. Tuple variable. So let me explain the meaning. Think of an implicit tuple variable or iterator. When we write a for loop, while loop, we need an iterator, right? We need a counter variable to help us going through. So we need a special variable to help us go through all the iterations in a for loop, in a loop. Here we have the similar situation. But here, the loop is whole table. Here, so we need to imagine. Here we're talking about query result. So this is a table. This table is the query result table. Okay. Query result table. So it's different from original table. Okay? Query result table. Query result, because we need to combine, data from multiple tables, then do projection. We do a lot of operations, and finally, we get a table structure as our query result. All right. But because this table, we need to do a lot of steps to get this table. Okay. Intermediate, we need to combine several tables. And when we try to combine data from different tables, so this variable, this implicit, so you cannot see it. So this variable is useful to help us understand step by step, connect all the tables, try to streamline the logic. That's the purpose for this tuple variable, this special concept. So its role is as this iterator. That's the role of the special variable, iterator. Going through all the rows in certain tables. Iterator. From beginning to end. In certain order, in the natural order of the table. All right. Looping over each individual tuple in the table. In the table. So here, this in the table, a little vague, because when you need to understand one special query operation, you may have multiple tables, right? Yes, multiple tables. So you use your query variable in which table? Which of the tables, right? So later we will get to the details, because we have inner table, outer table. So the tables, they play different roles. You have inner tables, outer table, all right? Just like inner loop, outer loop. Similar to the loop situation. In your programming, you need to write for loops, nested for loops. Here we need to have the nested query structure. Later we will understand. Here I just give you, high-level abstract description. Later, we need to understand nested query structure. So that part, relatively hard. All right. So looping over. All right. Evaluating the condition in the where clause. So then in the where clause, then you need to use this iterator. Yeah. Which one you need to fix it, and which one you need to go through all the rows. Yeah. That kind of details. Yeah. You need to consider in your where clause. Yeah. All right. Only those tuples that satisfy the condition are selected. Yeah. True, false, yeah. True, false. Yeah. Remember, when we learned the Boolean logic in SQL, Boolean logic. Yeah. So there are 3 Boolean values, right? Yeah. 3 Boolean values. Yeah. True, false, unknown. Okay? Yeah. So there is a third one. So here, this is a special one. Okay? Yeah. Yeah. Special in SQL. In other programming language, we don't have this third value. We just have true and false. Yeah. So here you can see, because the reason I talk about these 3 values, look at this last slide. Only those tuples that satisfy condition. What do you mean satisfy condition, right? Because the condition, these conditions, they are Boolean expressions. The condition would return one of these Boolean values. Yeah. True, false, unknown. Yeah. Unknown, when you have null value. Remember this unknown, if not involved. When not involved, you may have unknown. Yeah. You may. So here I say you may. Yeah. You may or you may not. It depends on the situation. Yeah. 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 I don't know if I practice that or not. Yeah. So we will practice that. The Boolean, 3 different Boolean values. Yeah. We need to practice a little bit. Yeah. All right. Yeah. Yeah. All right. Yeah. So before the midterm, we need to do a quiz, and half of the homework assignment, half. Yeah. So, but that one, yeah, just here I make you aware of the situation. So that one, because we have less than 1 week. The midterm is 1 week from today, but that one, I may like to set that quiz and half homework assignment. Same thing, same assignment. Yeah, the quiz style. Yeah, but here we just want to practice a little more concepts in Module 3. Yeah, Module 3, we need to practice a little more concept. Yeah. Yeah. All right. Yeah. So for that part, we have less than 1 week to do it. Yeah. Less than 1 week to do it. Yeah. So if I post it tonight, yeah. So today you don't have time. Yeah. Starting from tomorrow. Yeah. Tomorrow. So Friday, Saturday, Sunday, yeah, because Monday is another class. Yeah. So you need to submit by Sunday, yeah, end of Sunday. Yeah. Or I can give you just a few more hours, yeah, because in our Monday's class, I need to talk about some of the questions a little bit. Yeah. Monday's class. Okay. So definitely you need to complete it before our Monday's class. Yeah. Yeah. So that's for the last practice before midterm. Yeah. Just let you know. Yeah. Yeah, because usually the question not very hard. Yeah. So you understand our question not too hard. Yeah. Yeah. So So this one is a little shorter than our usual quiz. Yeah, a few days shorter. Yeah. All right. Yeah. Yeah, but we won't cover module 4. Okay. Yeah. We won't cover module 4. Yeah. Still module 3. So that. Yeah. Yeah. All right. Yeah. So satisfy the condition. What do you mean satisfy condition? Yeah. So here, be careful. Yeah. The satisfy condition, we mean when you evaluate the Boolean expression of your condition, it must return true value. Then we mean satisfy condition. Okay? Yeah. So definitely not false, but not unknown. Not unknown. If the Boolean value returns unknown, then you cannot select it. Okay? If the Boolean value returns unknown value, we cannot say the condition is satisfied. Yeah. So this is a special point for SQL. Yeah. So yeah, you may see if I make question, I may use the wording like this. I said, so the tuples, those tuples are selected if the condition does not return the false value. Okay. So I may say in that way. Okay? Yeah. If we use the two-value Boolean situation, then you may feel it's true, correct. Yeah. But here we use three-value Boolean structure, Boolean logic, three-value logic. Yeah. So that it won't be true. Okay? Yeah. See that difference. Yeah. So I may give you that question. Okay? So I do not say true or false. I just say not false. Not false could be true, could be unknown. Okay? Yeah. That's special point. Yeah. All right. Yeah. All right. So this is this tuple variable concept. Yeah. Here, yeah, I spent quite some time here because later, when we understand nested query, yeah, so later we will have a relatively hard part we call the nested query. Nested, correlated, yeah. Nested, if it's not correlated, that's easy, okay? Nested, correlated queries. That would be hard, okay? Nested, correlated queries. Yeah, that would be hard, okay? Yeah. So, that would, all right, yeah. Next example. Illustration using an example. Here, we need to see a concrete example to help us understand two-table join operation. Here, I want to explain step by step. We have 4 different steps. So here, I split into the details. 4 steps. The first time, when we understand this table join operation, yeah, so we split into 4 steps. Yeah. Because later we won't do this. Yeah. Later, so we only do things in our mind. Yeah. So we won't do all the details like we are doing here. Yeah. All right, so let's look at example. Yeah. Yeah, so this example, this is our old one. So here I use our old query example. So what's that? Yeah. So we need to find the name and address of the employees whose department has the name research. The department name is the research department. That's simple. Yeah. Yeah. But in this simple example, let us go in under the table join operation to see for each step what's going on. Yeah. Yeah. All right, so let's start. Yeah. All right. First, we know we need two tables. So we join two tables. The first one, employee table. Second one, department table. The first employee table, here I use our company database. So our company database. So if you want to look at the details, you just look at the company database. Employee table, in this parenthesis, there are 40 employees. Total, 40 roles in that employee table. Department table, in this parenthesis, there are 6 departments, 6 roles. All right. Now, let's do table join. The first step when we do table join, first of the total 4 steps. So our first step. Before we do the first step here, I use the symbols S1, S2 through S40, represent 40 rows of the employee table. T, department, I use T1, T2 through T6 to represent 6 rows in department table. Now, the first round join, Cartesian product. So last time, we used the math concept, Cartesian product of 2 sets, of 2 multisets. Here we treat these 2 tables as 2 multisets. All right. Although they are sets, no duplicate rows. But in general, in the more general situation, we only require 2 tables multisets. All right, Cartesian product. What do you expect? Cartesian product. Employee table cross department table. How do you form this cross product table? All right, that's easy. The first few fields you take from employee table. All the attributes you take from employee table. So you put here. All these attributes from the employee table. Then the last few attributes you take from department table. All the attributes. All right. So you put them in the same table. Okay. As the attributes of the new table. Okay. New. Cross product. New table. All right. You can always do this. In this way, you will have 240 rows. 40 times 6. Cartesian product. You multiply these 2 numbers. Why 40 times 6? You get that many rows. It's simple. Because look at that. S1, T1. S2, T2, and so on. For each S, you need to map it to 4 departments, 4 rows. But that's just for 1 employee. Second employee, you also need to map it to 6 departments, another 6. But you have 40 employees. So you need to map to 6 departments 40 times. So that's why you have all the possible ST pairs. SI, TJ, all such pairs, you have 240 such pairs. Straightforward understanding. So this step, you can always do this. Given 2 tables, you can always do Cartesian product like this, or cross product. Cross product like this. All right. 10 columns. So this first part, 10 columns. Okay. S part, you have 10 columns. T part, 4 columns. Department table, 4 columns. So for the new table, you have 14 columns. 14 columns. Okay. Add, put all these different attributes together. All right. Yeah. That's step 1. Step 2. Now, here we are at step 2. All right. Step 2, we need to apply table join condition. Join. Because these two tables, we need to join these two tables based on a table join condition. Okay. So what's the table join condition? Yeah. Yeah. So here, we apply table join condition on these 240 rows. Each row is 14 tuples, 14 attribute, 14 component tuples. Yeah. Yeah. All right. So we start from this point. Yeah. Now we need to look at the table join condition. This is table join condition. Okay. Deno, yeah, department number. We intentionally use a different attribute name. So we know it means department number, but we want it different from the D number here. D number, Deno, yeah. Yeah. To join these two tables, Deno number should, in the employee table, should be the same D number in the department table. Then we can say this row satisfies the table join condition. That's simple. Okay? All right. So we apply table join condition. We go through all the 240 rows one by one. Okay? If this condition is not satisfied, cross out. Eliminate it. Only when this condition is satisfied, we select it. All right. So our step 2, we do this. Yeah. So we use the join condition to, help us eliminate those rows that do not satisfy this join condition. Yeah. So the remaining 40 rows remain. Yeah. Yeah. Because each employee has one department row corresponds to it. Yeah. Yeah. Only one of the 6 department rows corresponds to one selected employee. But you have 40 employees, so you have 40 selected rows left. So after step 2, you have 40 rows left. All right. Third step, we apply select condition. This is the select condition. Okay? The D name, we go through all the 40 rows and see which one satisfies the select condition. Which one whose D name equals research. Then we keep it. If not, we eliminate it. Okay? Yeah. So that's our third step. Using the select condition to help us filter out more rows. Yeah. All right. After this step, only 4 rows left. 4 rows left. See? Yeah. Starting from 240, reduced to 40, now reduced to 4. Because only 4 employees belong to research department. Okay? Research department in this company only has 4 employees. Yeah. All right, so, yeah. All right, but each row still, they have 14 tuples. Yeah. The attribute number, 14 different attributes. But we do not need all of them, right? Yeah. More than necessary. Yeah. So our last step, projection step. So we only select required fields from these 14 attributes. Yeah. So the last step, we only select 3 of the 14 attributes. So that's the final. So we do projection, step 4, so we get 4 3 tuples. Okay? Each tuple 3 fields. So the result is, this is the final result. Okay? Yeah. So this example gives us complete understanding of the table drawing. Yeah. Yeah. What happens behind the scene? Okay? So you cannot see, it's not visible. It's not visible. So inside DBMS, the DBMS follows these 4 standard steps to produce the final result. Okay? Yeah. So with this background, so then in future, when we work on our own queries, yeah, so we need to get into the, the fundamental, yeah, behind the scene to understand how to get a query. Okay? Yeah? All right, question. Oh yeah, good. Yeah, good question. Yeah. So we have several types. Yeah. This join, we do not say what kind of join, right? So that means we use the default join. Default join, what do you mean the default join? Inner join is the default join. Okay? Yeah. Because when we use inner join, we do not need to specify what kind of join it is. Yeah. So that is the default join. Yeah. Yeah. And here, you do not even need to say join. Yeah. So yeah, let me show you our old statement before. Yeah. Let me move to here. Look at here. From this from clause, we put 2 tables together. We do not say what join, right? Yeah, because it's a default join. The default join, we do not need to say anything. Okay. Yeah. But if you want to say join, inner join or join, it's fine. Yeah. Later we will use that keyword explicitly. Yeah. So, and there is some, readability. Yeah. Because when we do that, probably readability is better. Yeah. Yeah. All right. Yeah. And the left outer join, left to right, that's the outer join. Okay. Left outer join, right outer join. Yeah. 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 We will get there. Yeah. But the first one, default case, inner join, and we do not need to say anything on inner join. Okay? Yeah. Yeah. All right. Yeah. Yeah. All right, so we finish this example. Yeah, I think it should be enough. Okay? Yeah. So we finish part A. Yeah. Now, let us move to part B. Yeah. All right. Part B, yeah, we need to go to another level of details. Yeah. All right, yeah. So more select statements, insert, update, delete statements. Yeah. So actually, yeah, we only talk about insert statements. Yeah. 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 Other, even simpler. Yeah. Insert, we have a few cases. Yeah. So for others, so we, just straightforward. Yeah. B.1, yeah, the first topic, resolving ambiguity in select statements. Yeah. So now, this detail, because think about, when we join 2 tables, we use the same concept. Yeah. I mean, the same attribute in 2 different names. Yeah. Think about dno and the d number. So that's the department number concept, right? But we use 2 different names, but here there is an ambiguity issue. Yeah. Because when you say dno or d number, which table has this name? We may get confused, right? Which table? Yeah. Employee table or department table? Which one has which name? So we couldn't remember. Yeah. So here we need to resolve ambiguity, yeah, in this first topic. Yeah. Handling ambiguity. Example. Yeah. Let's look at another query question. For every project located in Stafford, project table. Here, we need to use the project table. each project has a location. Yeah. So here the location is at a staff of this place. Yeah. List the project number, the controlling department number. Yeah. Each project must be controlled by certain department. So the controlling department number and the department manager's name. Yeah. This query. Yeah. So here you can see we need a use project table, and we need to use a department table, 2 tables. We need to join these 2 tables. But in this example, we focus on the ambiguity issue. Yeah. Ambiguity issue. All right. Yeah, so these 2 tables, yeah. Manager's last name. Oh, manager's last name should come from employee table. So another table, 3rd table. See? Yeah. Yeah, because only employee table contains the name of all the employees. Yeah. So we need that table. Yeah. All right. So these 3 tables, project table, department table, and employee table. Yeah. Here we do join operation on these 3 tables. Yeah. But when you do that, you just do 2 at a time, right? Yeah. 2 at a time. The first time, join first 2 tables. So you get a resulting table. Yeah. Next time, then that result table join with the last table. Yeah. So you can join any number of tables. Yeah. All right. All right, so here, the select statement. Select P number, D number, department number, P number, project number, department number, last name of the manager, manager's last name, L name, okay, from employee table. Yeah. All right, now, yeah, resolving the ambiguity. Yeah. From 3 tables, project, comma, department, comma, employee, 3 tables. Yeah. So here we use inner join, so we do not need to specify what kind of join. Yeah. Yeah. We do not use the join keyword. Yeah. Yeah. All right. Yeah. But here, think about, yeah, we can use the same way to that we use to understand 2 table join. Here we extend it to 3 table join. Okay? 2 table join, we do Cartesian product, A cross B, right? A cross B. That's the 2 table join case. But here, 3 table join, A cross B cross C. So 3 table join. Cartesian product, cross product, we can do 3, right? Yes. For example, A table, we have S, J, S, I, yeah, let me use I, okay? Yeah. Rows. B table, T, J, yeah. C table, S, T, R, K, okay? All right. Then, A cross B cross C, we form a new tuple, the first part of the component, Si, second part, Tj, the third part, Rk. That's how you form the tuples for 3 table cross product join. Then after that, you apply join condition, but this time you have 2 join condition. Okay, between table 1 and table 2, you need, this is the join condition. D-num from project table equals D number from department table. Okay? Yeah. So you go through all the tuples, only when this condition satisfied, you keep the rows. If not, if this value you know, when you look at the big joint table, that big joint table, if this condition not satisfied, you eliminate. Okay. Then you apply second joint condition. This is a second joint condition. Yeah. Because in a department table, the manager has its SSN, Social Security number. Yeah. Manager's SSN is used in the department table. Yeah. So you look at that value. Then employee table, you have this SSN value. You compare. If they are the same, you keep the row. Otherwise, you eliminate. So another round elimination. Yeah. But this time you join another two tables. Okay? Yeah. So you apply table join condition, two different table join conditions. Okay? To eliminate many rows. Then the last step, you apply the select condition, P location. P location from the project table. Yeah. It should have the value Stafford value. Then you select it. Otherwise, other different values you eliminate. Yeah. So after these 3 rounds elimination, the remaining rows, so that's what you want to, so the DBMS generates the remaining rows, but do projection. Only keep these 3 attributes. Do projection. Okay? That's the meaning. Yeah. 3 table join. Yeah. All right. Yeah. But here we need to look at the ambiguity question. Yeah. Because here you can see D number, D number. What are these attributes? Where do they come from? Right? Yeah, we don't know. Yeah. And so because there are 3 tables, it's hard to identify which attribute from which table. It's hard to see that. Yeah. Sometimes we may get confusion. Okay? Yeah. So here we want to find a way to clarify it, to resolve the, ambiguity. Yeah. There is a simple way to do it. Yeah. All right. Yeah. So here, our first try. So there are a few ways. The first try. Yeah. First try, how to provide the table information. We need to know which table provides this attribute. Just use the table name directly. Okay? Add the qualifier using table name. Table name as the qualifier. Okay? Yeah. So project.p number. Yeah. We use the table name to make sure no ambiguity. You know which attribute from which table. Okay? Yeah. Employee.l name. Okay? So each attribute we use the table name. Yeah. That's the first way. But you can see you need to type many characters. Yeah. See, people want to use simpler way. Yeah. So this way, too much typing. Yeah. So you want to save as much typing as possible. Yeah. So the next idea, you want to use aliases, not the full table names. You want to use aliases. All right, so alias-based solution. Because it will be much shorter, alias. Right? Yeah. Create an alias for each table name to avoid repeated typing of long table names. Yeah. So more efficient. Yeah. All right, to do it, yeah. So you can use the as keyword. As keyword. In order to define an alias, there is this optional as keyword you can use, optional. Okay, yeah, all right. Or it can directly follow relational. You do not have to use it. You can skip this as keyword. Yeah, all right. So let's look at a newer, simplified version. First, in the from clause, we define 3 aliases. Project as P, department as D, employee as E. Here, one thing I may like to make a comment. Here, this project, department, employee, actually we do not have to capitalize the table names. We do not have to capitalize, okay? Remember, our convention tells us we only need to capitalize keywords, right? SQL keywords. If non-table keywords, so usually we do not capitalize. Here, table names, they're not keywords, okay? Yeah. So here I use the capital, I mean, our textbook, capitalize it. Yeah. Actually, in the real world situation, people, most of the time, people do not capitalize, table names, field names. Yeah. All right? Yeah. Mainly capital letters reserved for SQL keywords. Yeah. Just a comment. Yeah. All right. Then, after we define these 3 aliases, P, D, E, then everywhere we just use P.dnum equals D.dnum. Here we know which attribute from what table. Yeah. No confusion, no ambiguity. Okay. Yeah. All right. So here you may ask. So if we have 2 tables with the same initial characters, that's fine. You just use a different way. Yeah. You can use 2 characters. Yeah. So if you like, you just use one more character, okay, or another different character. So you can find a way to make different aliases. Yeah. All right. Yeah. So then those as optional, because many times people just save those, do not type those as keywords. Yeah. All right. So here in this version, All right. Yeah. Second example, 2 different copies from one table. This time, you have to use aliases. Otherwise, you have problem. Yeah. So what's that? In this example, we need to use employee table twice. The first time we use it as the employee table, second time supervisor, because we want to get a supervisor information. Here, this question, so we want to get employee, first name, last name. Each employee, we want to list who is the supervisor of this employee, right? So it's supervisor's first name, supervisor's last name. So we need this information, and we need to use the same table twice. The first time for the employee, second time for the supervisor. The join condition, employees super underscore SSN equals supervisor tables SSN to join. Okay? So then, this time, think about, you cannot omit the alias E or S. Otherwise, which copy are you using? So big confusion problem. Big confusion problem. Okay? So for this case, you cannot omit the aliases. But if for other situations no confusion, then it's optional using aliases. Although based on our experience, we know in the real world situation, even if there is no confusion, it's still highly recommended people to use aliases to improve readability. Yeah. Readability. Yeah. More readable, so you make your SQL statements more readable. Yeah. People immediately they can identify. So which table owns this attribute and so on. So when you especially you need to join multiple tables. Yeah. So the table, the qualifier information is useful. Yeah. Yeah. All right, so that's the alias solution. B.2, set operations on queries. Set operations. This time, we need to combine multiple subqueries. Yeah. Subqueries. Yeah. In several different ways. Yeah. This is one special way. Yeah. Set operation is one commonly used way to combine different query results. Yeah. Yeah. So let's look at using set operations to represent queries. In math set theory, we know set operation, right? Union operation, intersect operation, and negation, right? Not. Yeah, remember not, negation operation. Yeah, and so on. Okay? Yeah. Another one, subtraction, subtract. Yeah. Another set operation, subtract. Yeah. We need to use. Yeah. All right. Borrowed from mathematical set theory. That's our background. Yeah. Yeah. All right. Set union first. Yeah. So our operator is called a union. Okay. Yeah. Union. All right. Yeah. So you have two query result tables. Two query result tables. Result A table, result B table, then you use union operator to combine the results from two tables. Yeah. So that's the first operator. Second, set difference. Yeah. Set difference. Yeah. So here, set union. Yeah. If I draw a diagram, A, B, yeah. Union, this is the union, okay? This is the union. Okay? Yeah. Easy. Yeah. But the difference, set difference one, except in the first result table A, you want to subtract second one, except. The keyword we use except. Okay? All right. Except is the keyword. All right. A here, B here. All right? Yeah. A except B. Okay? The part that's inside B is removed. Okay? This part inside B removed. Okay? Removed. Okay? So that's called A except B. Here we use except. Operation. Okay? Subtraction. Yeah. In set theory, we use subtraction. Yeah. Set theory, we do not use this keyword, except. Okay? Set theory, you can call minus. Yeah. But a set minus is different from our usual minus. Yeah. Some of the authors, they try to differentiate, because if you use minus, people may use the regular minus understanding, but it's not a regular minus understanding. Yeah. So in set theory, people use A backslash to represent set minus. Okay, A minus B. Yeah. So backslash, not forward. Forward slash division, right? So backslash, that's the minus, set minus. Yeah. But that's the set theory, okay? Not here, not in our SQL. In our SQL, we do not use this notation. Yeah. We do not use this notation. Because our backslash, we have other meanings. We don't want to use our backslash, it's a special symbol we need to use for other meaning. Yeah. So we use this except keyword. Yeah. But except keyword, the question is, it may not be supported by some of the DBMS. Yeah. MySQL does not support it. Yeah. This except key operation, this one, this keyword, this operation is not supported in MySQL. So we cannot use this operation in MySQL. Yeah. The reason, it's too complicated. Yeah. But we have a different way to get around it. Yeah. In MySQL, we will find a different way to do the same thing, but without using except. Yeah. Yeah. All right. Set intersection, intersect. Yeah. So that's simple. Yeah. Yeah. In our usual intersection, it's intersect meaning. Yeah. All right, so these three basic set operations. Yeah. Yeah. But here, another thing you need to be aware of is here, we call it set operations. Set. Set, that means no duplicate rows. When we talk about set, we mean we do not allow duplicate rows. Okay? Yeah. Yeah. But in our SQL, in business, we need to include the duplicate rows. Yeah. So here, for the set operation, we need to have different version for multi-set case. Multi-set. So we need to have the operations for multi-set. Yeah. All right. Yeah. All right. Yeah. So there is a condition. Yeah. So we will move to multi-set case soon. Yeah. But here, when you apply these set operations on table A, table B, can you always apply these operations, table A, table B? Right? Yeah. Do you need to check certain conditions, table A, between table A, table B? Right? Yeah. Yes, there is important condition you need to check. Table A, table B. Yeah. So what's that? Here, a condition. It's called a union compatible relations. Table A and the table B, they must be union compatible. So A and B, we call them union compatible, then you can do set operations. If they're not union compatible, you cannot do set operations. Yeah. But what do you mean union compatible? Yeah. Here, the meaning is pretty straightforward. Union compatible. Yeah. What's that? Same attributes. Table A, table B, they must use the same attributes. Yeah. All right? Yeah. Same names. Yeah. Attribute compatible. That's still not enough. Although you have same attributes, if you arrange them in different orders, still we do not treat them as union compatible. So same attributes, they should be arranged in the same order. Yeah. Same order. ABC here, ABC also here. Okay? You cannot BCA. Yeah. Yeah. The second one, BCA, it's not union compatible. Okay? All right. Yeah. So the attributes appear in the same order in both relations. Yeah. So if you have all these aspects satisfied in the condition, then you can say union compatible So you can apply these 3 set operations. Otherwise, syntax error. Okay? DBMS will check if they are union compatible. So DBMS would reject it if it's not union compatible. Okay? Yeah. All right. Then, multi-set operations. Now I talk about multi-set operations. Yeah. Because we need to allow duplicate rows. Yeah. Set A, we keep duplicate rows. Set B, we also keep duplicate rows. Yeah. Yeah. So how do we make multi-set operations? Just change a little different on the set operations. Yeah. We use union or. So we add that keyword or, union or. Then you can apply this operation on 2 multi-set tables. Union or, okay? Except or. Yeah. This time you preserve the duplicate rows. Okay? Intersect all, you preserve duplicate rows. Yeah. Yeah. Union compatible. Okay? Yeah. All right. Yeah. Yeah. So here I just give you, the high level, the rules, basic rules. Yeah. Later, when we have a little more time, we will get into the details. Okay? Yeah. So I may try to create some examples to show you some subtle cases, some conditions, because you can find some special cases. So we can look at it. Okay? Yeah. So when we join 2 tables with duplicate rows, so we want to see what happens. All right, yeah. So here we just, first we understand the rules. Yeah. So later we may practice many examples. Yeah. Try to understand better. Yeah. All right. Yeah. Each tuple duplicate or not. Yeah. Because some tuple, you have duplicate rows. Same tuple repeated 1, 2, 3 times. Duplicate or not is considered as a different tuple. Yeah. This rule is important. Each tuple inside the duplicate rows, you have to treat them as different tuples. Different tuples. Okay? Yeah? Yeah. This rule is important. Yeah. We need to keep this rule in our mind. But we need to get some experience. Yeah. How to use those rules. Yeah. Yeah. All right. Yeah. Yeah. All right. Yeah. 5 more minutes. Yeah. All right. Example, set union. Yeah. So that's our last slide. Okay. All right. Look at this example. Question: make a list of all project numbers for projects that involve an employee whose last name is Smith. Employee. Yes. Some of the employees may have this Smith. Yeah. You may have more than one. Okay, several. Yeah. Last name is Smith. But the Smith either as worker or as manager. You may have the Smith worker or Smith manager. Okay. So you need to include both cases. Okay, yeah, all right, of the department that controls the project. Okay, so the manager of the department that we treat this together. Okay, this condition, control the project. Yeah. Yeah. All right, so here we split into 2 parts. First, Smith as worker. Second, Smith as manager of the department that control the project. Okay, all right. So we need to write 2 queries. Then we combine them. Okay, we take union of the two result tables. All right. So first the worker, second manager. All right. So the first part here, as worker, because we do not look at manager or not. Okay. So we use the works on table. Works on table it's a relationship table. It provides the mapping between employee and a project. Okay? Employees working on projects, so you have the relationship. So you use this table to give you that relationship. Okay? So that project, employee, this relationship table. Yeah. All right. All right. So distinct P number. Yeah, some project repeat it, so we remove, duplicate. Yeah. Then we combine tables, two places. Yeah. All right. Project P number equals the P number, because this P number, we know this P0 is in the employee table. Okay? Yeah. So that join. Yeah. And ESSN, that's in the works on table, and the SSN employee table. So we join. Yeah. Yeah. All right. Okay. So in this way, yeah. So we join. Yeah. All right. Three tables. Yeah. Then the last name, Smith. Yeah. Here you can see we do not use the aliases. So we do not use the qualifiers. So you can see that would make our understanding a little harder. Because you try to figure out. So P number from which table? P0 from which table? ESSN from, here we know works on table. SSN from employee table. Yeah. But you keep asking yourself these questions. Yeah. So that's why it's highly recommended we use aliases. Even that there is no confusion. Here, no confusion. Yeah. All right, so this is our first query. The second query, this time manager. Yeah. So we need to use department table. Okay? Yeah. Here we do not use works on table. Here we use manager table. Okay? Project, department, employee. All right. DNUM, department number, DNUM, and the D number, yeah, because here, yeah, yeah, all right, yeah, so here, yeah. Yeah. Department number, right, the control department for the project. Each project, you need to have a control department. So DNUM, that's the control department of project, okay, yeah. So manager, MGR underscore SN from department table, SN's from employee table. Yeah. Okay. Then last name equals Smith. So for Smith, with different roles, employee role and the manager role, yeah, employee role, manager role, all right? Yeah. Then you run two separate queries. Yeah. Query 1, query 2. Two separate queries, but they are union compatible here because the projection P number here, P number here, they are union compatible. So you can take the union. Yeah. If not, yeah, if you put some different information, not union compatible, you cannot take the union. Yeah. All right. Then you take union to get that. Okay? Yeah. So here, so that's the result set operation. Yeah. So you may want to ask, what's the difference, right? Smith work on this project as employee, and Smith, control department manager. What's the difference, right? So you may ask yourself that. Yeah. Actually, there is some difference, because when the roles are different, you may see the difference. Because the department manager, that's the manager, whose department control this project, but that manager, that employee, that person may not work on the project directly. You can imagine that situation. Okay? That manager does not work on the project directly, but his department controls the project. Okay? You may consider that situation. Yeah. So these two, you look at the information from different angles, different views. So your result should be different. Yeah. All right, so let's stop here. Yeah. Yeah. So, somebody asked a question. Oh, yeah, somebody asked questions. Yeah, let me look at chat.